Good morning and welcome to day 2 of our online learning. So we are moving right along into our next section of chapter 6, which introduces you all to the imaginary number I. You may be wondering why on earth are we looking at imaginary numbers, but as you know with math, there are always new number systems that are being invented, and this is an example how a group of mathematicians got together and decided that we needed to be able to solve equations that involved numbers that were negative underneath of the radical, and so the imaginary number I was invented. And so we are going to take a look at this idea and see how we can use it and incorporate it into solving different problems involving radicals. So I put in this guided notes in this purple rectangle here the very definition of I. So I is equal to the negative square root of 1. And then if you were to square I, so I squared, would give you an answer of negative 1. So therefore, if R is a positive real number, then you can see that if I had the value of negative R and I took the square root of that, that is now equal to I times the square root of R. So we're going to take a look at this definition and how it applies to the example below that you can see. We've got part A, which is asking us to simplify the square root of negative 5. So if you think about how we were solving or simplifying radicals before, we always would break these into kind of like a tree diagram. So if I take my negative 5 here, and I'm going to break this into the square root of negative 1 and the square root of 5. And then if I go back to my definition, which is up here, right? This definition right here, we know that I is equal to the square root of negative 1. So this now becomes I, and then the square root of 5 cannot be simplified further, so this answer now becomes I times the square root of 5. Alright, so go ahead and pause and see if you can answer B and C on your own. Okay, so let's go ahead and break 25 into two different components of the square root of negative 1 and the square root of 25. So this now becomes I, and this becomes 5. So therefore I can just rewrite it as 5I as my answer. Alright, and then if we move over here, we have the same thing. We're going to break this into negative 1, and then I have the square root of 50, which I can then break into the square root of 2 and the square root of 25. So I know that this is equal to I, this is equal to 5, so therefore I'm going to have an answer of 5I times the square root of 2 as my final answer. And there you have it. Alright, so let's take this a step further and take a look at our next examples here. For example 2, we're asked to simplify. So again, we're going to just simplify each of these radicals and then combine any like terms that we may have. So you may be able to start to see this. If I've got the square root of negative 16, I can change that directly into 4I. And then the square root of negative 49, I can change that right into 7I. And I am subtracting the 2. So if I have 4I minus 7I, I get an answer of negative 3I as my answer. Alright, and then with part B, this one we take a look at, can we break down square root of 2 any further? No, so we just look and see, oh, they have like terms. They both have the square root of 2, so I can go ahead and combine that. So 1I and 3I make a total of 4I. and then I still have to keep that square root of 2 as my final answer. All right, and then scrolling down at our last set of examples, in example 3, we're going to take a look at this. Now, our first inclination may be to multiply these two together, and unfortunately, in this definition of imaginary numbers, this, when you multiply those together, does not give you the square root of 100. So they need to be first expressed as radicals with their pure imaginary number before you can do any simplifying. So you need to first turn this into 2i. Let's close that out. And we need to simplify this into 5i. And then we can go ahead and multiply these two together. So I have 2i times 5i, and that gives me 10i squared. And then if you recall, if you go back up to your original definition, so I'm going to scroll all the way up to the top again, this definition here, I squared is -1, right? So, go back down. If I squared is -1, that means I'm going to multiply 10 times -1, and that gives me an answer of -10. This is my final answer. All right, so let's take a look at example B. I'm going to go ahead and multiply these to each other. So I've got I and I, that's I squared. And then I've got the square root of 2 times the square root of 3, which I can multiply together because there's no negatives in there. And that would be the square root of 6. All right, so we need to ask ourselves, can we break down the square root of 6 into perfect squares? That's not possible, but I do know that I squared is -1. So this now becomes -1 times the square root of 6, which is also equal to negative square root of 6. And there you have it. There's your final answer. So I will leave you to it to complete your next assignment, which is found down below. You're completing page 290, numbers 1 through 21 all.